All right, well, good morning, good afternoon, good evening, and thanks for joining us for the first part in our KubeAcademy Office Hours Core Concept series, where today we'll be covering platform. As you can see, these handsome fellows here to the right, we're joined by Ryan Schneider, Neil Winton, and Bill Cable. But before we jump into today's topics, just a few housekeeping items. We'd love to keep this interactive, so if you have any questions, please feel free to use the Q&A button or the chat function below to get your questions and comments to us. We'll do our best to answer them live today. And if you're not already part of the over 60,000 KubeAcademy learners, it's free to join. We'll make sure to include the link to start your free membership in the chat. Now, without further ado, let's hand this off to today's speakers, right?
Great, thanks, AJ. Hi, I'm Ryan Schneider here at VMware, lead education engineer, and have produced a lot of content on KubeAcademy as well as some other courses. Certified Kubernetes administrator, been working with Kubernetes for about 4 or 5 years prior to coming from both system administrator and the application developer and architecture arenas. And I'm joined by two of my colleagues here at VMware, Bill and Neil.
Hi there, Neil Winton. As Ryan said, one of his colleagues there, also working in Tanzu learning. I come from a strong, long software development background, but also have been on the sharp end of operations as well. So seen a lot of the stuff that's brought us to the widespread use of Kubernetes that we're seeing now. Bill.
Hi, my name is Bill Cable. Like Neil, I'm working in Tanzu Learning. We're working on building out some educational content. And my background's pretty varied. Similar to Neil, I've drifted over about a 25-year career spanning operations and development. I would classify myself as a jack of all trades and master of none.
Great. And so I'm in Florida in the US. Neil, you are in?
I'm in England. I'm in Felixstowe, which nobody has ever heard of, so that's fine.
And Bill?
And I'm in Chicago.
And I'm sure we have folks from all over the place. Sometimes it's fun if you feel so inclined, drop a 2-character, 3-character code of your city, state, or country, or providence in there. It's sometimes fun to see those go through. And while that's going on, so once again, thank you all for taking the time to be here. Basically, in KubeAcademy, we have a lot of content, both lecture and lab content. And we wanted to take some time so you can ask us questions, right? We have this, it's a great resource for on-demand, self-paced, but sometimes you're just like, I'm curious. I want to ask the person who made this why they did it that way or why something behaves that way. And so this is your opportunity. And so if you go to KubeAcademy, you'll get all of this here. And one of the things we added was this learning paths. And one of the learning paths we're excited about here at the bottom is this Kubernetes core concepts. So a learning path is made up of courses, and each course has lessons. And the idea behind the learning path is let's string together a series of courses that make sense where it collectively provides you an overall learning objectives, right? And so in this part, these are the concepts of Kubernetes that we really feel are the best to learn about, that everybody should know, regardless of your role, whether you're running applications, building applications, or building Kubernetes clusters and trying to keep things running and going. Now, if you click on the path here, this is where we're at, and I can drop this in the chat as well. This is where we're at, and we're going to focus on part 1, which is about containers, the fundamentals of Kubernetes, and then how it's sort of built and troubleshooting. Now, when we put this together, you can go out here and actually take one of the videos and watch all the content. And you can, I can bore you to death with my little small video window there of myself as we go through the material. And so hopefully a lot of you did that as well. And then what we like about this learning path and the course associated with it is that for every single lecture or topic, we have an associated lab. And so if you click the lab associated with it, I've done this before, and start it, the lab environment will load here. The lab environment is a combination of the lab instructions as well as a remote cloud Kubernetes cluster where we do our work. And so what I'm going to do to sort of get things going here is that sort of sets our pace for this. And this is part one we're going to focus on today. In about a month to month and a half from now, I don't recall the exact date, we're going to be doing the same thing again with part two. Obviously, we can dip back and cover some topics we might have missed here, but we're going to do the same thing with the parts as we go along. And so maybe to start with this, what I'm going to do is please, as you have questions, ask them. Bill and Neil are going to be helping me out for a lot of the stuff that comes in, but I'm going to start stepping through the first lab of this, so people can see what's going on and sort of set our pace. It's also important to note one of the things we like so far on this learning path is that we have a theme. So if we go back to all those courses that were in here, the lab exercises, the application we use, and so on and so forth is all connected. So we have a consistent story. So with that, let's get started on this. So with this environment, right, where do you put your images when you make them? Well, we got to put them somewhere. We don't want to rely on an external one. So we actually have image registry that's running that's unique per your environment. So this one here is unique per your session that you just launched. Feel free to follow along in here if you'd like. You can, once again, it's free. If you don't, just sign up if you need to. And I'm currently doing this lab of lab one of part one. And so we have an application here. And let's go ahead and do the next step, which is we're going to get the files we're going to work with. So this is a two-tier application. Let's go look and see what unpacked. Okay, so we have this thing called Go Web App. All right, and inside there, we have two things. Let's do some poking. Well, if we're a bottom-up thinker, we'll go to the database first. Okay, so all we have here is literally a SQL file. Well, let's take a look at it. Oh, okay, so this is the schema or the DDL for the database. All right, well, that helps us there. And then let's go take a look in the front end, which it most likely is. All right, so we have some code. And it looks like we have a binary. Let's do 13 megabyte binary. Wonder if I run it, what happens? Gives me an error. Not quite there yet. Okay. Let's look in static. A lot of stuff I'm not good at, like making things look really good with CSS. Okay. And let's look here. Template. Okay. More probably generated HTML that's going to be substituted and so on and so forth. Okay. I get a sort of feel for this. Now I can go back over and do something I'm normally not good at personally, which is following instructions, right? Let's go back over here. So we're going to write the Docker file for our front end. So let's go to that directory. And it says, hey, create a file named Docker file in this directory, and then use an editor, and let's put it together. So we can use VI. I can make a Docker file. I could take the contents of this, and it wants me to populate it. So I'm going to go ahead and do that here. Okay. And we got these to-dos. Okay. And so let's go ahead and, if we don't know what's going on, basically, right, we can click these links and we can look, and it's going to help us, right? A lot of the labs we write, we like them to be objective based. So you go look at what's there. So here's the various versions of the Ubuntu image and the information about it. And then Docker file, when we use the from line, we give it a name, the name of the image, and optionally a tag, which is the version, right? So here's some of the tags that are available. But our instructions basically told us to use a specific tag. what did it want us to use? It wanted us to use Impish. Okay, so, and it wanted us to use Ubuntu, and we're going to put in that optional tag name. Then it wanted copy statements, and we have links to this. I'm not going to show all of it here, right? But it's basically, I'm going to shorthand it because you can go through the lab yourself as well. We're copying the code directory into this location in the container. Just quick reminder, this copy command is not something that's executed like when I do CP in my terminal window, and it's actually affecting the machine that I'm typing the command on. Instead, it's affecting the image that we're building, not my machine, right? And this one wants us to copy ./config into opt go web app /config. And then finally, it wanted an entry point set. And it has, if we were to follow this link here, we will see an entry point here where it says, hey, we got two forms of it. And it's what command, when the image, the container starts up, do we want the container to start with? If we don't put anything of this, then we're required to tell the container at runtime when we started out what to launch. In this scenario, we know what we want to launch. We want to launch that Go Web App binary no matter what. So we're going to put it in there. Oftentimes I get asked the question, well, what's the difference really between this version and this version? And you can see there is a succinct difference. The shell form, it's essentially one string. Okay. Up here, it's an array of strings. The shell form requires that the image that we are going to put our application in has a shell in it, like sh, like bash, etc. Because the shell does the work of parsing that string, figuring out the different tokens, expanding things, passing on the arguments to exec, and so on and so forth. Here, this is why it's preferred. If you are putting your application into a container that did not have a shell, then this will work, and this one will not. Okay, entry point. And then we are going to do, it tells us in the comment here, opt/go web app/go web app. Okay. So once again, we did a lot of opt Go web app, right? There is no opt Go web app here. And what we'll see is after we do the instructions to do the build, which is right now, so it successfully, and it put the stuff into opt Go web app config, right? But if I look at this stuff, opt Go web app, well, guess what? Doesn't exist here. That's because my changes didn't happen on this machine. It happened inside the image that I built, right? There's the one I started with. That was the from line. And then I used that as a base, and then I added in, right? And if we actually did like a what's here, right? Notice, not bad, right? 15, basically we added 15 meg on top of 77. Roughly gets RSR 92. So things check out. Okay. So now we got that. Let's go do the same thing with the database. And we're going to make a Docker file here. Okay. This one's a little bit easier. If, just as note, if you are ever having problems when you're going through the labs with us, at the bottom, we do have a solution section. And for the sake of time on our webinar, I'm going to copy them from here. But I do highly encourage that when you are doing these, try to use it as a last resort. You know, fight through it as much as you can. As you know, a slang in the Americas of give it the old college try. On this one, you might be wondering, what's this copy thing we did? Well, part of that was in the to-do from up here. It said, hey, figure out where to put this file. The creators of the MySQL Docker image said that any files that you put in this directory, when the container launches, it will scan them and it will try to run them appropriately. And this allows you to initialize your database, which is what we're going to do here. Okay, let's do the build. This one's a little bigger. Very, very true, Marcia, there. There's a lot of tries needed. It's better than what it used to be. All right, so let's make sure this thing works. We're going to create this network. It's basically a way for us to, you see when we do this Docker command here, see how we gave it a -net? This name here matches the name up here. And what it allows is when we gave the host name of Go Web App MySQL, imagine we put it all of this, we're launching all this stuff inside the same subnet, right? So everything is shorthand addressable. We don't need fully qualified names. And that's just, we get sort of that DNS help in here. And it'll be important because if we go back to here, if we go into the Go Web App thing and we look at that config and we crack open this config, see, the username and password to talk to the database are here, and the host name is Go Web App MySQL. This allowed us to be a little like, we're assuming that there's a DNS name called Go Web App -MySQL. By issuing those Docker commands we did previously, we basically get that. Okay. I think it's been about 20 seconds, but let's go make sure, do a Docker PS to make sure things are running. Yes, it's running. Great. And remember, you can always do a -A if it's not there, and it'll show you what's crashed. And do our good old friend logs. And cool, we get that magic line with the version and the socket number. All right. Let's do run the front end. Up 6 seconds. That's great. Cool, we got it. Okay, and test it. In this environment, we have an ingress running. So everything's dynamic. So this is the URL to the running application. Ooh, look at that. Here we are. Let's register. Cool. It worked. Great. No, don't save. Okay. Cool. Great. Okay. We can also exec inside containers and make sure things are working. I'm going to stop for here. We did this on the Docker side, right? Does anybody have any questions here before I throw it in Kubernetes, and then we will start to sort of see it from that aspect. Let me do a time check here.
Yeah, there was a question that came in saying, is the password in the lab text? Yeah, so all of the information that you need is in the instructions of the lab. Also, should probably say that if you go through the video lectures before this, that will remind you, if you haven't used Docker before, that will introduce a lot of those things to you. So if you're unfamiliar with Docker coming into this, it gives you enough information there to make sense of the lab.
Yes, and also technically, if you wanted to run this thing like on Minikube, Kind, or your own Kubernetes cluster somewhere, everything that you've seen here so far will work. The things you got to change are the registry where you put the images, right? We're using that dynamic registry here, the one of echo registry host. You'd need to use Docker Hub, AWS ECR, your own registry like Harbor or something like that. But other than that, everything here is pretty generic. Okay, so what's our favorite thing to do when we create something in computer science? That is to delete it. So let's throw it away. Okay, so it's gone. And then arguably we did something like testing locally. So let's tag this stuff. And if we now look at Docker images, type correctly, Ryan, notice, if you recall to sort of how the image world works, we have two image IDs that are exactly the same size and the same created time, but we have two different repository names associated with them. Sorry, technically, yes, two different repository names. Notice this one has a prefix on it, which is basically it has the host name in it. This one doesn't have the host because it's implicitly referring to our local cached image. So when we do these push commands that we see here, that's when it goes. So we're pushing it from the normal work behavior here would be like your laptop or your build machine. So your GitHub runner, your GitLab runner, your Jenkins, whatever it may be, that runner is built the thing, it's locally there, then we push it outside of there to something else, and then we blow it up from there. All right, cool. Let's terminate this. I don't see any container related questions drop in, so let's do that. All right, I am back. We're on to lesson 2, but let's do the fun part of it. Let's do the lab of lesson 2. Restart this thing. Now, if you recall, I told you that these lessons are connected, right? They have a common theme that goes through them. And so for that, one of the things we do as we start to go through here is we have a bootstrap command. We like to make things flexible, just like we do in software development, right? So you can actually arguably do this all in one setting on one machine. And we do have some formats of this course where we do that. Or here where we have a whole separate environment for it. So we're going to do this. Notice here, if I do a Docker PS, nothing's running. And notice if I do a Docker images, I don't have any images. It's a new environment. So let's go ahead and run this command. And what it's going to do is it's going to get us back up to essentially end of lab 1. This is also helpful, right? If you had some trouble with one of the labs, it doesn't prevent you from starting one of the next labs. Okay. So it's basically scripted and it's doing all the things we did in the previous section and using those solutions as well. On a side note, if anybody's ever curious about it, these kind of things, this fast forwarding of the lab or the bootstrapping in education, we like this because it's sort of the rough equivalent of integration testing that you would do when you're writing code for applications where, all right, well, if I can bootstrap the lab to this point, I'm essentially running what the person going through the lab would do. So if we replay our commands, we have images now. And but nothing's running. Okay, great. So ready to keep going. All right. Peter has a question in the Q&A. This lab can be formed on Google Cloud Platform in the GSCTL terminal line. And if so, what would the registry change be? If I recall, I'm not completely fluent on Google Cloud's built-in command line, but I believe you do have access to Kubernetes and to Docker. In what we just talked about, which was Docker only, it should be there. If not, you could launch a machine and get to your Docker. So if you do a Docker and Docker spits back help to you, then you're good. So the answer to your first question, yes. The registry change would be up to you. So you could, if you're running in Google Cloud, you could go and make a container registry in Google Cloud and then use that one after you create it. Or you could use, if you're wanting to play around and you're putting stuff into something like GitHub, GitHub has built-in registries that you can use for on a per repo base, and they're called packages, GitHub packages. So that would be the other thing that you could use. Those would be the two recommendations I would have. The Google Cloud one first, since you're in that environment, or the Google package ones. You bet. So let me start here into the Kubernetes world. Our command we use is kubectl, right? Sometimes called kubecontrol. And kubectl has some things that are your friend. You can use explain and give it the name of things, and it will basically, it dumps the documentation to you, the reference guide. You can also get this by browsing the actual reference for the objects in the Kubernetes documentation. But if you're a person who likes to see it in place, you could arguably, it would be similar to man pages. The other thing that is helpful here is at most places within kubectl, you can double tap and you will get autocomplete. So in this case, what are my available things after kubectl? Let me get some stuff. What can I get? Sure, let me look at all the things. And if I want to type one letter and then double tap, I get some completion, right? All right, no pods running. Let's have Kubernetes run this application for us. So the first thing we're going to do is we're going to go and get the database set up. Now, if you know from Kubernetes, and if you've gone through the lecture there, there's two classic or main objects that are used when doing when making putting application to Kubernetes, and that is a deployment and a service. Okay, the service is like a load balancer, right? And so what we do here is we're going to do, it tells us, hey, let's make a file called go web MySQL YAML. Okay. And once again, we have these to-dos because we just had you run commands all day long. That wouldn't be any fun. We got to mess up sometimes. And so the idea being, right, if we go back up to the top here, we have a link. And if we look at the definition of a service, we will see some examples here, right? And so in our lab, we're asking you to give the service a name. Things are sort of already indented to help us. But so is it literally name colon? Let's see, it's below metadata, above labels. Let's go look. Yep, it's literally name. Okay, wonderful. And remember, labels are arbitrary key pairs. I could put pizza, you know, it doesn't matter. I can put whatever I want. In this case, we are choosing to use app and then give it a value of go web app -MySQL. Kubernetes doesn't care what values we use. However, the relationship, the person writing these things, the author like myself, does care because these will matter later on. Expose port. All right, 3306. Let's go back to our help here. So it looks like service here, name, okay. Ports can have a name, protocol, port 80, and target port. Okay. All right, supported protocols, TCP. It's the default one, so I don't need that. I could leave it off if I wanted to, and I bet you the name might be optional as well. So I could try it without. It will yell at me if I have it wrong, right? So let's do port 3306. Okay. And let's do this selector of app. Go web app, MySQL. We did it once here, and once again. Okay. So just for giggles, let's comment that out like that and save this. I'm going to go ahead and apply this. Remember, kubectl apply is how we get stuff in to Kubernetes, and we get an error, as I had anticipated here. And the error is basically saying, hey, you're missing stuff. A lot of times people tell me, like, you know, get cryptic. The messages from Kubernetes are cryptic. I will tell you a few things here to help you. If I go look at that error message compared to, let's say I leave off, let's say I put, I leave off this, I butcher the YAML. So I do something like this. So notice the error message here really has nothing to do with Kubernetes, right? This is, it's a parsing thing from one data format to the other. So we're having a problem parsing YAML to JSON. It gives us a line number. This means my issue is nothing to do with Kubernetes. It has to do with the syntax of YAML itself. The one up here is a validation error. Notice it actually has Kubernetes things in it, right? It has service and ports and array numbers and API namespaces and etc. And it's basically saying I'm missing the required field of port in this object at this location. Well, if we go back, we can totally see, let me fix my indentation here, right? And there's that missing field port. Put it back in, let's see it go. Did I still screw it up? Spec, ports, port. See where our message is now. Oh, map. I need my, I got rid of my dash to really butcher it, didn't I? Much better. Quick reminder in YAML, right? A dash represents an entry in an array. Ports is an array or a map in this scenario. So that went into Kubernetes. It's the pod. Can I get services and see it? Yes, I can. There it is. And I can describe that service and get it back as well. Tab complete is your friend, double tab. In this case, it was the only one, so it came back. I'm going to quickly do the last one here, but I'm going to do it from the solutions to help us for the sake of time, so we make sure we have all the possible answers. Or can we get to all the questions? Okay, come back to here. And it wants this file, the next one we were asked to make after the service was the deployment. It's all there. Okay, let's apply it. I can safely do another trick here. If you do the current directory or put a directory in, kubectl will rip through them and try to apply all YAML files. It does it lexicographically in the order that they're in the directory. Just remember, there's no transactions here, right? So if it gets through one of them or all of them except for one, well, guess what? All of them except for one actually happened. Let's see. Oops. I have some pods. Image pull back off. I forgot to do the replacement step right here. That's because if we looked at the YAML beforehand, if you remember the registry in here is dynamic, I said. And so we couldn't hard code and tell you what the registry was. We wanted to actually see it get replaced. So if we, there we are, we're running now, much better. And tab is your friend. And there's our same log message as we saw when we ran it manually. Okay. Let me pause here, see if any questions have come in that we need to have some discussion about or some new ones. And then if not, we are at 137. We don't have, I'll pause again here. Once again, I know it takes some time to get your questions in, formulate them, etc. Or if you're thinking about something or trying to follow along. But in the meantime, I will just, for expediency, I will also prep and launch the last lab, which involves some troubleshooting, just in case we have some time to get to it. Okay. So I'm going to go ahead and do the bootstrap thing just so we have that available for us. And once again, sort of shows that I'm not much use, right? Because I could just run this command and do all the work I just did. But we're going to build those images. Since this is free, we are going to write those YAML files and get it all running in Kubernetes. And I will come back and get lab 2 back up over here. It will save my. Should still be in it, hopefully. I didn't terminate it. Yep, there's the end of what I was doing before. Great. Finished fast forwarding. Let's see. There's my images. Now, let's see if we do a kubectl get pods. Look at that. My 2 web servers running and my database. And this is probably the best point to start with if people have questions, because I have everything up and running. So if you want me to break something, if you have questions about what's running, let me know and we can dig into that now. And in the meantime, if you were curious, yes, it's already hot here in Florida. And I think actually, while I'm letting some questions come in, I'm curious to see. So a lot of us here have traveled around. So Wisconsin, I have been there. I've been to Milwaukee for the most part. Austin, Texas, probably been there 20 so times all over. Really a fan there. Oh, I probably have a package or something. Tennessee, yes. Illinois, Chicago, and the suburbs. North Carolina, my brother lives there. London, yes. Philly, yes. Texas in general, New York City. I used to live in New York City. Philly, yes. No to Fairbanks, Alaska. I have not been. Connecticut, yes. CLT, is that Cleveland? Airport code? Kansas. Yes, Kansas City. Or no, I've been to, sorry, that's in Missouri. I've not been to Kansas. Colorado Springs, yes, I have a good friend who lives there. Virginia, yeah. I was hoping for some Detroit. I did. I'm trying to think of the customer. Ah, Charlotte. Yes. Been to Charlotte, and I've also flown through Charlotte many times because I prefer Delta as the airline. And Miami, you're just a little bit away. New Hampshire. Nope, have not been there. Thanks, Doug. Take care, man. Have a good week and good weekend. New Jersey, I've been to the Garden State. 30. Arizona, Tucson, yes, and Phoenix. Germany, yes, I've been to Munich, Frankfurt, and somewhere else. Okay. I have not been to Oktoberfest in Germany. It's on the list, and then something 2 years ago prevented me from going. Is the storage running? We have a question. Is the storage running in a storage application like Firebase? So the storage for two parts here. The storage in this case is actually using MySQL as a persistence mechanism. The storage right now at the current point is going ephemeral into the container. So that MySQL container that was started for us inside the pod by Kubernetes, it's just writing into a spot. So if we go into that, oops, sorry. Mixed up, huh? Okay. Yes, I have no name. Thank you. So I'm inside a container, inside the running Go Web App container. And I think it was opt-date. There we go. All right, so you see this directory here? This is where the data is being written. We see some January, we should see some time frames here. We actually went into it, my apologies. Down through here, we'll see some recent stuff. This data is actually ephemeral. So if I restart this pod, right? Well, I can't really restart it, but we can use the power of Kubernetes to really muck with it, right? And most notably, we can see it, we will see that that data will disappear, all right? So that's where it's being written right now. And we intentionally do it this way because there's no persistent volume set up with this running application. If you go into the learning path of this course, this learning path, we're going over the Kubernetes core concepts. Later on, and next we get to it in one of the webinars, if you come back, when we get to down here, we will get to stateful applications where we actually say, how do we plug in persistence to this? Pods and containers can come and go, and they can switch from machine to machine. So the storage needs to move around with it. The backing storage can be anything we want. In our YAML files, technically, it doesn't know what storage it's going to get. It may be getting an NFS share. It may be getting a AWS EBS volume. It may be getting some iSCSI storage. We don't know. That's handled behind the scenes. And if you're curious, the form that you fill out, the ticket, as I like to call it in Kubernetes, is called the PVC, the persistent volume claim. And if you look that up, that's basically as a person who wants to run something in Kubernetes and is asking for storage, just like if I emailed the IT staff and said, hey, I'd like storage, it's basically a ticket like that. Okay. So another thing I can do here is if I go, sorry, this is lab 2. If I go back into here, all right. If I go to temp, try to Okay, right? That file is there, right? In temp. Okay. Now, if I do a kubectl delete pod, I'm basically forcing a problem here. The delete commands in Kubernetes with kubectl do, they do wait for the action to be completed where the other ones don't. And there we are. The new one's running 11 seconds ago. All right, let's do an exec in. It's a different pod ID, right? So MySQL. My apologies, I just ran the wrong command. And then we'll finish up here in just a moment. And I will answer, it looks like Neil's answering. VJ has a question. I'll also answer it live if in case anybody else is curious.
That's why I'm straight off, Ryan.
Let's exec into this new pod that it spun up. It's not there just to prove that, right, the demo folks are with me. There was a question about, that just came in and then we'll be done, about the order of how would I do order. And that's how we typically think of things. But Neil is writing exactly what I expected him to, which is that ideally we want to design our applications so they don't care. By default, Kubernetes is going to restart your pods infinitely. There's some back off, linear and exponential back off retries that happen, but it's basically going to go forever. And so what you want to do is, in this scenario, it's eventually going to work. So it doesn't actually matter which one came in first. Now you're going to reduce the amount of noise or turmoil from a log. Like if you're looking at the logs of the cluster itself, you might see like pods crashing or restarting, but it shouldn't hurt anything. You can control it with some of the other mechanisms that Neil mentioned. There's a lot to that, but that's a general philosophy behind that. Okay. I'm going to, let's see, time check. We are at 10 till. I'm going to wait for some, I know, hand it back over to AJ here in a little bit, but I just do want to say a few things else about what we went over. I skipped the lecture part. The videos are there. I'm happy to go into them if somebody has a specific question about a specific slide or topic. But if you go to the videos, please, by all means, let us know how we do. We basically always try to introduce the concepts first here, right? And we'll have some code snippets and stuff and guide you, and the labs will reference them. So if you're having trouble in a lab, a lot of times step into here and we do give some flavor and some context, and it will help you. And then, like I say, I encourage you to go through this. When you get through it all, remember that the learning path is made up of a bunch of parts and it builds on it. So some of this stuff here might be a little bit new or to folks. Some of it might be a little bit of a review. But as we go through this, we start to really layer in some upper level concepts about how networking works behind the scenes. People ask all the time, you know, where do I put things? How many things do I have? And so on and so forth. And we go into that, as well as storage, which is always the elephant in the room in talks, and then some security and the way you can make Kubernetes do things other than just run long running services like web servers and databases.
There's another question that's come in, Ryan. Did you just want to take that one?
Sure. I think we can get it done real quick here. Is there a use case where 2 or more pods need connectivity between namespaces? If so, how can it be done? So yes, that could totally be a possible scenario. And when people come to me and ask these kinds of questions, a lot of times, one of the things I do is I say, let's ignore Kubernetes and let's think about the relative equivalent that we have in the IT industry. A pod is roughly like a virtual machine. And the applications that are installed and running on the virtual machine are roughly like the containers that are defined for a pod. And a namespace is roughly like a DNS or a subnet. So when I think of one pod needing to talk to the other, I don't really think about singularity. I think of an application, because it might be one or many pods that need to talk to a different application made up of one or many pods. And in that scenario, the easy answer is you can do it and you reference the service name that's in the other namespace, but you have to use a fully qualified DNS name. Inside Kubernetes, it runs its own internal DNS by default. Depending upon your deployment, check with your administrator. It may have some other plugged into other DNS within your organization, but generally speaking, it runs its own. And you reference that with not just the name of it, but it will be dot. So in this case, our service for our database was go web app-mysql. And our config.json for the web front end had that in it. However, that's all we needed because we were in the same namespace. If you're in a different namespace, we would need to say go web app-mysql dot the name of the namespace that those service exists in, and then the actual name of the cluster. Excuse me. One small caveat I do want to mention is, and it's always on the security side, if you have network policies and stuff set up that prevents outbound or inbound communication from the namespace, you might need to work with your network administrator or write network policies to allow that within Kubernetes. Depends upon what approach was taken within your cluster. Does that sound about right, Bill and Neil?
Pretty comprehensive answer, Ryan.
Okay.
And there is there are modules later in the course as well that deal with some of those issues as well.
Yes. Oh, very good point. I almost forgot there. And we have lab exercises where you will specifically see that put to the test. So you'll have stuff running in 2 different namespaces and you'll get to see it and do it hands-on and not just rely on us telling you. So thank you. All right. We're at 5 till. I think we've made it through most of the material for part 1, as well as fielding some questions, talking with you folks, and doing labs that for the most part worked out okay and didn't mess up too many commands. And so I think with that, we'll continue to answer in the chat, and I'll also turn it back over to AJ.
Thank you, Ryan. Thank you, Bill. Thank you, Neil. That was a great presentation, great walkthrough for KubeAcademy and through this core concept course. If you've seen in the chat, I think Ryan had mentioned before, we'll be doing a part 2 to the series sometime in June 16th. So please look out for that registration page and email that we'll be sending out shortly with you all. We did receive a few questions here in the chat as well regarding the recording of this webinar. This has been recorded and will be available. There's a link, I believe, that Neil had put in, but we will also send out an email to everyone that is registered with the video link as well. So feel free to watch it again, to share it with your friends, or to also dive yourself into the course as well. I think you can see it here still on your screen from Ryan's screen. So with that being said, once again, thank you, Ryan. Thank you, Bill. Thank you, Neil. Thank you all for the kind words and comments in the chat, for all of your great questions live. For everyone working in the background, Marissa and Meghna, thank you again. And we hope to see you guys at our next event. Thank you all.